Hey everybody, welcome to WasmCloud Wednesday for Wednesday, September 17th. Um, I have a feeling I'm going to be talking at you a lot today, so hopefully that is enjoyable for everybody. But feel free to stop me if you have questions or comments or concerns or anything like that. So why don't we go ahead and share the agenda? Today's demo and discussion items are going to be pretty meaty, I think. It's going to center a lot around this pull request that I opened in the Wash repository, which is uh, kind of around consolidating the libraries that we use to run WasmCloud. It's somewhat around some of the issues that we have in progress on the roadmap right now. So specifically, configuring a Wasm Cloud host kind of statically, like with a set of components and providers and things to run, supporting component to component calls on the same host without like going out to NATs, transitioning capability providers to wRPC servers or endpoints, and reducing the host responsibility and API surface. All of those kind of feed into this. And I'm I'm hoping that we can go through a pretty fun discussion on this kind of evolution, like moving towards the next version of Wasm Cloud, since we've been on 1.0 for about a year and a half now, all the way up to 1.9. We've had folks that have been running in various stages of dev, QA, production for quite a while. So I think I mean, we don't know everything. And I'm trying to represent the ideal features from all the feedback that we've gotten from the community and from folks who are running this. But if your perspective isn't shown in some of this stuff, then please let me know. But there are some changes that I think we wanted to make ever since, I mean, honestly, since we released 1.0, like everything has things that we want to change. So I want to talk about this PR, and then I have some fun diagrams to take a look at. And then we can talk about like this next branch on the documentation too. So this pull request, let me go ahead and link it in the chat. There's a lot going on here. These 12,000 lines they're not all wit and cargo.lock and stuff, but a lot of it is. So this Wasm Cloud, and please don't let the, V2 next discussion worry anyone about like big breaking changes or like things are changing completely. This is really just the version that I picked for the Wasm Cloud crate. Um, because the Wasm Cloud crate right now is on, 1.9. So evolving past that. So this crate, which we've introduced into the Wash repository, or will once this PR goes in, is the Wasm Cloud crate. Now, this is something the Wasm Cloud crate today in the main project monorepo is just the binary target. So, like when you run the Wasm Cloud container or the Wasm Cloud binary, that's what you get. But this Wasm Cloud crate is essentially it's a library and a binary target, but it consolidates the Wasm Cloud host, the Wasm Cloud runtime, and Wasm Cloud core libraries. Now, I know this is just a bunch of words and libraries and things, but these are all of the different Rust libraries that we maintain internally. So what we found is that the separation of these crates isn't necessarily productive for adding new features to Wasm Cloud. It's not a separation that we need to have, and it also is. It can be difficult to add features or to embed Wasm Cloud or to extend the host in your own ways with the current like library architecture. So what I wanted to do was take the API surface that we know and like the simple idea of like here's this application or set of components and here's all this configuration. Can you deploy it? And then later along the line, like, can you stop it? And then can you deploy this other thing? So an extremely simplified version of the Wasm Cloud control interface, which I'm just calling the host API. So this host API is internally just a trait that we implement on the host that supports scheduling workloads, which are a collection of components, configuration, very similar to the idea that folks have of a WADM application today. You know, it's a declarative set of all the things that you want to deploy with a name. It has a namespace associated with it, like a lattice, but it's a collection of components, and that's what the host can support. It has an engine, which this engine is very similar to the Wasm Cloud runtime, if you've ever interacted with that. But the nice thing is that the thing that the engine is really responsible for is taking these multiple components that are in a workload, linking them to the Wasmtime linker so that you can do WASI 0.2 things, and then components can also call each other. So I tried to link to things on the roadmap as they come up in this PR. And then it also supports host plugin implementations, which is a pretty much wholesale replacement of built-in capability providers. Now, built-in capability providers are nice for some cases. You know, it's good to be able to skip like the wRPC transport for things like HTTP incoming and outgoing that you're doing all the time. But building these into the host required you know, cloning the host repository and then modifying code internally. So what I wanted to do is add a essentially plugin mechanism where you can embed the Wasm Cloud host. And then I'm going to use this immediately in Wash. I can have a plugin to run Wash plugins, a little meta. But having this makes it a lot easier to embed the Wasm Cloud hosts and kind of extend it statically, especially when an external capability provider isn't a great fit. And I have an example of that I'll bring up in just a little bit. This crate comes with a couple example of plugins, so you can see how this works. And hey, this is a note that I was going to bring this up in this community meeting. Look at how fun that is. So let's talk really quickly about and folks, if you have questions, just raise your hand. It's all good. Oh, hey, Taylor, muted? Question mark? Oh, okay.
Can you hear me now?
Yeah.
Aha. Okay. The a question on three, I think, because you and I've talked about the host and host plugin stuff before, and I just wanted to make sure. So the will the wRPC layer also be a host plugin in this new thing? Is that the plan? Because that seems to make sense to me, but I wanted to check that that's how it would be. So like if you still want to use a remote provider, you can still do that, but it's via the wRPC only added via plugin. Is that correct?
Yes, yeah, that's
Okay.
the thought. So we would have a wRPC, transport plugin, and then when you deploy your little workload of components, you say, hey, for these sets of interfaces, say WASI key value and then my org, my package. For these interfaces, I want you to use the wRPC plugin. And then those, essentially will go over the transport when you run it. Um, Yes, the whole goal of that, wRPC being something that you explicitly opt into is to address this issue, this feature that we talked about on the roadmap, which is being very intentional about these are the interfaces that are going to go over, the NATS message bus or a TCP socket.
Okay. Yeah, that's what I thought it was. I just wanted to clarify because the wording on the PR you had was a little bit vague on that. So because it's saying
Yeah.
like it's almost saying it sounded like it was going to replace, but I did think it was exactly as you described though. So
Yeah. Okay. Good call out there. Yes. So in this case, you can replace the wRPC layer with some built-ins if you so choose to like pull in the host library or the WasmCloud library and embed it yourself. But I think for the vast majority of folks who are used to like the capability provider model, we can, they would use the wRPC built in to like go out to wRPC servers. Um, I do actually have a diagram for this, so it should be good. Let's take a look at that. So before we go any further, and thank you, Taylor, for bringing up things like wRPC servers. This crate doesn't have everything that wasmCloud has in it today. It doesn't have like a pluggable policy engine, which I know that we want to re-examine that API. It doesn't have like pulling secrets from like an external secrets operator. It's kind of assuming that you've done that already. So just like Wash, just like how the goal of this Wasm shell project, the next version of Wash or whatever, is to simplify down to the smallest bits. I wanted to do the same thing with the Wasm Cloud Crate, like focus on being a WebAssembly application runtime for a cloud and edge context, and just hit the basics really, really well. And then once we have that, building on top the external extensions, building on top, secrets if that needs to happen at this layer, building on top um I'm blanking on, a different example, but so this is intended on being a stepping off point, but it may not have everything yet. So why don't we take a look at some diagrams? So I've been doing a little bit of looking into this idea of C4 diagrams. And I mean, I'm gonna be honest, and maybe like if you worked on C4 a lot, like I'm sorry, but like generally I look at those diagrams and it's like, ooh, okay. But I do really like the idea of having a really like a high level view of the architecture, which the first layer is called like system context. And then essentially expanding out each individual layer. And then all the way at the bottom, you have stuff like class diagrams and code and things like that. I only have like two layers right now, but I think the system context should be a good first layer. And then the second layer is called containers, which is awful. So I call it application and services. And the third layer is called components. So we just can't be using those words for the diagrams. But anyways, looking at the system context for Wasm Cloud, things that we want to communicate on the high level on a docs page. A developer, a user who is developing Wasm applications will curl install the wash CLI. They'll use the new build dev commands to essentially do their developer loop with the language of their choice. And then when they're finished, they push that binary to an OCI registry. That's like our developer user interactions with Wasm Cloud. And it's really simple. You don't have to install multiple different things. Wash takes care of all of that. We have the edge engineer. I guess you could think of these almost like personas, but I like the idea of how people interact with the system. We have the edge deployers, the people who are running Wasm at the edge. The what we want to enable here is essentially running Wasm Cloud just as a binary, maybe as a systemd service. Wasm Cloud, the binary can run multiple workloads, and those workloads have multiple components inside of them. And then if you wanted to extend the host at runtime with a wRPC extension, wRPC endpoint, we call these capability providers right now. You can also run that as a separate service on your machine, systemd, just as a binary. It could be a container too, but really the point is that these aren't bound by the container box, and they can communicate back and forth using a wRPC transport, something like a NATS. Then there's the platform engineer, which this is the majority of folks that I work with when I work on people who are deploying Wasm Cloud. Lots of times in Kubernetes, it's not always. Like we have folks in our community, like Luke Ark, who's running a bunch of wasmCloud things as like on NixOS and doing it all with a flake, and that stuff's all awesome. I put that almost in the edge engineer category. But the platform engineer who's providing a platform for Wasm apps will interact with an operator, the Kubernetes API server, by applying this manifest of like, okay, go deploy my Wasm Cloud hosts, go deploy these workloads on top of those hosts. And what I really want to draw here as the boundary is that inside of your multiple Kubernetes nodes, you'll have Wasm Cloud running as a container. It's a container and not like we're not doing a modified we're not executing the WebAssembly on like container D or anything like that. It's in the container. We have our multiple workloads. And then distinctly different from today, where Wasm Cloud executes binaries for capability providers, I think a great model or where I'm trying to drive the wRPC extensions in the Kubernetes context is to run as containers that run, on the same node. Could be a sidecar to the Wasm Cloud container, but they can also just be their own containers. So really just trying to communicate the different bounds of the system. And then, of course, when users interact with this, it goes through all the classic load balancer, API gateway, ingress stuff. But all of that gets routed to your Wasm apps. So, uh, open to feedback on this one. I don't really want to spend too much time on this because I think everyone who's on this call is probably generally familiar with how we're running Wasm Cloud, like in a system context. But I think for someone who has never seen this before and they don't know how the Wasm is actually running, it'll be good to see the different bounds here. So if we blow up this idea of an individual application and service, this is where some of the more interesting stuff comes in and what I wanted to talk about today, because this is a view internally into the organization of Wasm Cloud and Wash. So here on the left, this is a generic box. I don't have the right I don't have all the right parameters here, but all you really need to know is that in order for Wasm Cloud to receive requests to start workloads to run components, there is ideally some control plane process that is making sure that workloads are being scheduled on the correct host, that they're being placed properly. Right now, for a Wasm Cloud, we would use Wadm for this or our Kubernetes operator, whether you were running in Kubernetes and sending commands all over the place, or if you were running, sorry, yeah, or well, whatever. But all we really need to know right now is that the Wasm Cloud binary um, is going to be something that is essentially a loose wrapper around Wasm Cloud, the library. And this is what we used to have as the host and the runtime and the core and all of that. So what makes up the Wasm Cloud system today is in this crate is the host, which is responsible for executing and organizing workloads. These workloads have a collection of WebAssembly components inside of them, and the engine inside of the Wasm Cloud Crate is basically a loose wrapper around Wasmtime, which is our Wasm engine. We have our specific set of built-in plugins that we support, like HTTP server, runtime config, logging, and tailored, just like you called out a little bit earlier, the wRPC extension, client plugin. So, if you wanted to make external requests to some binary running somewhere that's listening on wRPC, or some container, that is an external part to the Wasm Cloud host. We have been talking about this for a long time, and it really does simplify the management of a Wasm Cloud host locally, not needing to download provider archives, not needing to like spin out or like run uh, child processes from a binary. And I really think that's probably a better organization or separation of concerns. Wasm Cloud should be concerned with being the best Wasm application runtime, right? Not like running binaries. So, it's not a hard and set thing. I mean, I suppose this could technically run binaries too, but this is kind of the idea of the system. And what's really cool is from the binary side, we can actually, or from any binary that's embedding the Wasm Cloud library, you can provide your own plugins. Now, this is going to be really interesting for folks like, I know that Colin Murphy is working on Wasm Cloud org maintainer, is working on a presentation for WASI WebGPU. This is a type of implementation where if you're doing heavy GPU computations, you don't want to be sending all of that data over a network boundary or a network, whatever, over a network layer before you actually get to hit the GPU. So this is a great use case for embedding the Wasm Cloud, embedding the Wasm Cloud library and running it. I mean, WASI WebGPU, as it goes through its standardization process, this could just be an optional plugin that we include with Wasm Cloud that you can turn on and off, loading it when you run the host. And all this really does is it makes the host have a new set of interfaces that's available, everything that's in the WASI WebGPU suite of interfaces. So you get the message to the host right now, just strawman over NATs, whether it's in Watum or Kubernetes, and then you can orchestrate components within a single host. Notably, this kind of changes you don't see any interaction with Nat's Jetstream like today where we socialize links and configuration over Jetstream. It's not prescribed here. We don't require the use of Jetstream. I think our control plane layer, like the Wadum side, will be able to make use of Jetstream to socialize these workload manifests and make sure that we're sending messages to hosts that are widely distributed. But the host itself is not writing to a global state or trying to coordinate between hosts at all. It is only responsible for its own things. So I put some code here, just in its true Rust like fashion, but all you really need to know is that the if we take away a lot of what the control interface supports today that is a little more imperative, then it's a lot easier to reason about saying, hey, start this workload where the workload is hey, get out of here, some metadata, and then all of the components that make up a particular like application. I keep saying application and workload. I think they're very analogous. And that's essentially the idea of a Watum app rolled forward with a better degree of separation. And then workload component is just the ID, the actual Wasmtime component, the Wasmtime linker, and things like that. So that's Wasm Cloud, right? Wasm Cloud that you know and love and will be running is a lot more self-contained. It has some built-in plugins, but it's not as the built-in plugins are using the same mechanism that you can use to extend the Wasm Cloud host. So it's not so entrenched in it today where you need to like go modify the bindings of the runtime. You need to go modify the implementation of the host and make up an OCI, a fake built-in OCI reference, all that stuff. Yeah, Taylor.
Question around the like exposing capability. So any reconciler, scheduler thing on top of it's going to need to know what capabilities the host has. Is that contained in the heartbeat, or is that going to be exposed through some other mechanism?
That is contained in the heartbeat.
Okay.
Um, and I can actually pull that stuff up here in a
And do you still link? I was still reading through your code and looking at it, but do you still link to make sure you're granting exactly what you want, or is it going to be more of a if you're scheduling on this machine, you're scheduling it because you know it has X capabilities?
Yeah, a little bit of both. So right now, and maybe this will change based on what is the nicest to support, but right now the host heartbeat contains essentially the imports and exports that this host supports. Right now, I'm just marking like WASI 0.2 as like a given. Like you always have those, except for HTTP, like you can turn that one off. So these are the imports and exports that are not WASI HTTP. And then when you schedule a workload, you will declare like, hey, I need incoming handler, I need key value store and atomics, I need WASI config runtime, and here's my configuration, stuff like that. So it's not it's not linking so much as well, it's the same kind of mechanism as linking, but you're more so declaring the interfaces that you need, that you want to import and export, and the configuration that goes along with it, which is basically what a link.
Yeah, okay, that makes sense. So it's just basically clarifying the many times you and I tried to rejigger the links to make it look better. This is better. Okay, so that makes sense to me. I think that we'll just need to maybe clarify that when we start pushing this out. Like I said, this group's going to get it, but when we start doing it for other people, we might want to clarify what that difference is. Like the here's V1, here's V2, and maybe document some of that. But anyway, not that no actions there. I just was just making sure I understood.
Yeah, yeah, for sure. Yes. And then it's made worse maybe by the fact that we are letting you participate in the linker, like the Wasmtime linker when you're a plugin. Um I'll give you an example, say WASI logging. So the WASI logging plugin is a really easy implementation. This is how we implement it today in the wasmCloud runtime. But there really is no way to turn it off. But now it's a plugin. You can just feature flag it off or just not load it when you run the host. The implementation is really simple. When you log at a particular level, like warn, we emit a tracing event warn, and it goes straight to the standard error logs of the host. So when naming is all pending, so we can definitely bike shed on this. When a component is started and it says, "Hey, I need WASI logging," and you provide it, that is where this plugin gets to essentially add the logging implementation to this component's linker. So when the component says, "I need to make this log," that goes directly to this host implementation, which you can provide essentially externally to the host. So the the way that you link between two components or from a component to a plugin and then analogous like component to like the wRPC plugin will be essentially participating in the Wasmtime linker, which is and exactly how you would call any host function from the Wasm guest context. Now, I think that there's still plenty of error handling and making sure that two plugins can't register for the same thing in the host. But because these are all built in, we have a really tight control over their life cycle. And if you're embedding Wasm Cloud, you can provide your own, but you provide exactly what you want. Um, to give you a specific example of how I'm immediately going to use this and I'm still working through is Wash. So Wash right now for its dev loop essentially just embeds Wasmtime and Wasm Cloud Runtime, the crate, but it has a lot of logic on top of that for managing components, managing their life cycle, exposing the right bindings. But with this Wasm Cloud library and embedding Wasm Cloud inside of Wash, when we run the developer loop, we can start a workload with the component that the developer is like rapidly iterating on, and all of the plugins, like the dev loop plugins to implement extra interfaces. And then we can also provide a Wasm Cloud Wash interface plugin for plug. come on, 4 plugins so that we can execute, commands and hooks and things like that in the wash binary. So I basically am just getting to delete a lot of code out of the wash binary now. So now under wasmCloud and under wash, we'll have the same kind of unified crate with the higher level concepts. So, we're dogfooding this pretty immediately. I'm already finding stuff that could be better. So, just working on that one piece at a time. Yes. So, okay. So maybe let's take a step back here. Because hmm, no, let me talk about one more thing. I'm going to jump back to code one more time. So like I mentioned, these host plugins are able to participate in the linking of the component, like in the host. So if you declare an interface like WASI key value, we can have an implementation that maybe stores things in Jetstream, and we actually add that functionality directly to the linker. So when the component calls WASI key value APIs, that is going to be implemented by this host plugin. But but very key. One of the things that is a requirement or something that we talked about on the Cosmonic on the Wasm Cloud roadmap is da, 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 supporting in-process component-to-component calls. We've had some like experimentation on this in the past. But in the current Wasm Cloud host, every single invocation goes over the NATS wRPC transport, which has its pros and cons. But if you specifically, when you're scheduling your workload, say, hey, I want this workload to run on the specific host, and I want all 3 of these components to be running in that workload on the host, these components should be able to talk to each other directly. And that's one of the key things that is making it into this Wasm Cloud crate. And there's some, let's say, refactoring opportunities here. But when you initially schedule a workload, you get that scheduled essentially as an unresolved workload. And then internally, we resolve that by iterating all over all of the components in a workload. We check all of the imports and exports of those components, and we can directly define in the Wasmtime linker a host callback that, what's this word, trampoline? That kind of trampolines the calling of a function to another component. So scrolling all the way down here, this is all like pretty intense Rust, so thank you all for bearing with me. But we can define a new function in some component that's importing like, I'll give you the example that I actually have working here. I have a blob store. I have a component that's trying to use WASI blob store, but I do not enable the blob store plugin. I don't like Wasm Cloud knows nothing about WASI blob store. Never heard of it. Who's this man? I don't know. And I have a component which I've shown off in the Wasm Cloud community meeting before. I have a component called Blob Store File System. This component exports WASI Blob Store, so it provides the implementation of WASI Blob Store and uses WASI File System to back that interface. So you give it a file system pre-open locally, and it can implement the containers and object writing there. So what we do is we will say I call a function create container in my component. That'll define this new function in the linker that will instantiate a new instance of the blob store file system component, will call the create container function on that instance. That instance will of Blobstore file system will then create the folder locally and return that resource handle to the original component. And we'll reuse this instance for continuing calls of the same workload. So if I send an HTTP request, create a container, write some data to a container, and then finish that and then return the response, that'll all use the same instance. So they're kind of connected with their life cycle. Um, but that's exactly what this does. So when you run multiple components in the same workload that have matching imports and exports, we essentially link that together directly with this pretty lightweight trampoline. We just need to instantiate the other component if it doesn't or isn't already instantiated, and then call that function on it. So that's what I have working here in this test. I can run cargo test if, nope, not that one. Nope, not that one. Come on. Blob Store FS plugin. I can run this test if folks actually want to see it work. But the cool thing is I can provide this like local volume mount to this Blob Store file system plugin to say, hey, go write this stuff to slash data, please, and then provide my configuration and my interfaces that I need. And then all that we need to do on the side of the host is to start this workload. As soon as that returns and gives us our response, then we know that it's ready, so we can start sending HTTP requests. And what this component actually does is store things in a key value store and a blob store and make an outgoing request. So it's one of the better integration tests that we have. Um, so the issue that we have on the wasmCloud roadmap for in-process component-to-component calls is something that I have implemented and working in this wasmCloud crate. And the main reason why we did it in a newer or in the more greenfield area is that supporting this is something that does change the default for what Wasm Cloud invocations do. Like by default, we're going to try to resolve those dependencies locally so that we can take advantage of the super low latency component to component calls. So there's plenty more to, I think, discuss here to tease out like for different use cases when you would want to run it locally versus run it distributed. But I guess summing all of this up, this Wasm Cloud and Wash crate should be a really good foundation for us to test those assumptions to see if we are addressing the feature set from 1.0, which power the Wasm Cloud applications that we're really happy with today. Um, and then see where we can go from there. So there's other things that there's one other thing I wanted to point out from the community agenda, but do folks have any questions? I've been talking for way too long. Concerns, things that maybe you didn't see pictured here or want me to talk about a little bit more? Yeah, Frank.
So, I mean, a lot of those things, they look very cool and interesting. One of the things uh, and going back to, for instance, where are you getting the components from? Are they still OCI based? Uh, so now you're running Wasmtime on let's say on a container. So now you have to manage what's running on that particular container, so workloads and so forth. But one thing I'm wondering, and this is, I mean, you mentioned in terms of when you started, in terms of the whole simplification, and I'm wondering if you're also looking from the point of view of the whole, let's say, WASM value point of view, which is fast start, extremely quick processing, and very small footprint. So I'm wondering, I mean, are we also maintaining those points, or were we, I mean, by adding all those features, capabilities, and so forth, how much are we paying for it? Let me put it that way.
Yeah, both really good questions, Frank. I'll share real quick to answer your first one because it's a quickie. But from the perspective of like where we're getting components from, where we're getting, manifests and containers from, all that is still OCI, still using the same implementations. So, from your developer or from your CI/CD, you'll use a tool like Wash or OCI registry as storage to push your Wasm artifact to an OCI registry. And then, whether you're running as a standalone binary or as a container in Kubernetes, you'll pull that component from your OCI registry all the same. I think there's an opportunity to be able to start from a file too, but by and large, I think the OCI covers the vast majority of the situations. It's just really that we are specifying, multiple OCI references for the, in one workload, kind of like one application. Um, but to your second point around efficiency and, management, we are taking the same steps when dealing with WebAssembly components for efficiency that we are today. When you schedule a workload, there is that initial time where you could pull the component artifact from a location. We can cache that, or we cache that locally on disk so you don't keep pulling the same one. But once you've pulled that component, we essentially will hold on to a pre-compiled, pre-instantiated instance of the pre-instantiated version of the component that when an HTTP request comes in, we instantiate it and hand it the HTTP request and then reap all those resources. There is a notion in the workload of a pool. So you can determine a number of instances to actually instantiate ahead of time before a request comes in. I still need to implement that part, but that is a level of control that can even mitigate the minimal instantiation cost for a WebAssembly component. So you can take a slight memory increase for just getting the minimal startup time possible. But generally, I know that lots of words or some of the boundaries of what we're deploying is changing, but the way we're dealing with components is essentially the exact same.
Um, and one thing, I mean, just follow up to your sample that was actually returning a reference to a local files to a local file. So what do you do when you're crossing boundaries? So if you're running in different pods, so at some point you have to figure out, okay, that component is running remote, so I lose that capability of having this shared, say, file system, right?
Yeah, and yeah, it's a great question. So if the component's running remote, then at that point you have a choice to make. Are you having these two components communicate over a like strongly typed WIT interface? If so, you could replicate the same behavior as you would get today with the wRPC plugin. You say this component calls the other component. It's going to go through the wRPC plugin locally, which is or in process, which is the linking piece, and then it would go over like a NATS transport there. If you aren't having components communicate over a direct or a strongly typed WIT interface, then this would be a good time to consider connecting these components using maybe the HTTP capability or a message bus capability. So instead of going over the wRPC transport, you could also use WASI messaging, which we can have an implementation for NATs and essentially route to the component that way. That one, it's so much more custom per environment. And I know that I'm like enterprise splaining to you, but it's so much more custom per environment. What we see all the time is people have this like service mesh routing layer that they want to tap into, and going through wRPC and going through NATs is not something that they already do. So what we end up recommending anyways generally is like using HTTP and hitting your Envoy or your service mesh, insert service mesh here. So that is something we recommend so often that it's probably a good idea to just use existing tools and routing that you have if that's available. Does that does that speak to you, Frank? Like what you're interested in seeing, or do you feel like there's
Yeah.
more
No,
times
no,
that
definitely. I mean, I mean, I mentioned that earlier, but actually leveraging Kube will definitely accelerate the whole acceptance because now this is you're leveraging a platform that already exists and you're just adding the capability uh, of what Wasm and wasmCloud brings on top of that. So I think that's looking forward to experiment with.
Yeah, yeah, awesome. The goal, and I know that NATS is such a big part of our infrastructure today, like you have to run NATS when you run Wasm Cloud. I want to have a world, where if you can implement your application in terms of a set of components that use WASI P2 or P3, which includes like sockets and HTTP, and then we'll have things for built-ins for messaging and key value. Like if you can use all of those building blocks to make your application, then the only piece of infrastructure that you need to run or coordinate is this Wasm Cloud process. Decoupling that has been so nice for the local wash dev experience because I don't need to deal with any separate processes or like a network boundary. It's all kind of satisfied all within the same process. But then having the right cutouts so that you can use that system or use NATs more intelligently would be really nice. So I'm really interested as we start running some of the applications that we like the sample applications that we have as Wadham manifests now, like as a workload, how that feels, how if it's simpler, if it's more performant, all that stuff I'm really looking forward to playing around with.
Cool. Thanks.
Yeah, thank you, Frank. Okay. I will just call out one other thing that Eric has been working on. Oh, hey, Eric. Just jump in if you don't want me to steal your thunder. But
Steal away.
oh,
But
all right,
commonly questions folks might have.
awesome. Yeah, you made this, I made this. So under our documentation, I don't think this has been merged quite yet. But we have documentation back from pre 1.0 of Wasm Cloud 1.x, and then for now, looks we've been iterating on a version of a next version of the documentation. Said that Yordis isn't here to give a spiel about diataxis and all that fun stuff, but we are approaching the documentation just iteratively, just like we are with Wash and with Wasm Cloud, and starting from what the key developer flows are, the key operator flows, what are the Wash commands, which is a whole lot simpler than the last list. What are useful WASM tools, just essentially bringing things over piece by piece from the 1.x documentation. So if you are taking a look at the docs and you see this, do not be afraid. But what we notice is that there are, a couple of things changing in the Wasm Cloud world here, and we definitely need to start documenting the different diagrams, the interactions of Wash. Where'd you go? The different interactions of Wash and how you configure local component files. So all of that's happening here under Next. No action really here for anyone who's taking a look. But just to note that this is something that we're working on, and when the time is right, we'll just change the default version on our docs to be the next version, and then make a big shebang and tell folks to reinstall Wash and all that fun stuff. But again, nothing really happening now. We're still very much in the exploratory phase of landing these new features. But it's going really well, and for most use cases that I've tried out on wasmCloud, I mean, I haven't found one that doesn't work well in the new model yet, and it is a heck of a lot nicer to work from the context of like a nicely resolved workload over like, oh, I want to add this little extra thing, so now I need to make this capability provider, and then I need to package it up in 5 different architectures and yada yada. Okay, well, I'm just ranting now. So, Eric, anything else that you wanted to say there that I didn't capture well?
No, that was perfect. The changes you showed are up in the PR now. There's some discussion about how exactly we want to implement the next version and structure that. Anyone who wants to, pitch into that conversation is very welcome. But otherwise, yeah, I think some form of that next version is where we'll be iterating on these changes going forward.
Awesome. And big shout out to Aditya and Eric again for putting together some of the Excalibur library, the community Excalibur library, which helped me make some of the architecture diagrams here. We'll have to all get synced up and kind of reconcile some of those to make sure that they're in the right like Excalibur, wasmCloud language and all that stuff. Um, so yeah, I think that's all that I had, other than shouting at all of you for 50 minutes. Does anybody have any other questions, any other thoughts from the discussion today?
Thank you, Brooks, for sharing your magnum opus with us. It's pretty great.
Yeah, same here.
Well, hey, I look forward to drawing up some more stuff, sharing some more things, and having folks try out Wash and wasmCloud. It's all I think it's all looking really nice, and by and large, I don't want to mistake um I don't want to conflate like being more simple with always being like better or whatever, but I find it, for being in the ecosystem for so long, I find these ideas to be so much easier to understand and relate to like the existing way that people run applications. So I really hope that other folks do too. So that's the goal. Yay, clap. Alrighty, folks. Well then I think we can go ahead and cut it for this week. Got some fun things. I will regretfully not see any of you for the next 2 weeks. I'm going out on vacation for a little bit, so this will be hosted by someone else who is also very, very cool. And I don't know, I think we've got some really cool things planned for the next 2 weeks, like diving more into the Kubernetes piece, and there's some things moving around in WASI P3 right now. So plenty of fun stuff. We'll be sad to miss it, but looking forward to catching up with you all on the next Wasm Cloud Wednesday.